Fifth assignment. The assignment given to you by your course coordinator, DN Singh sir. Because I'm going to start the fifth live session right now. Am I audible? Okay, Gaurav, I'm starting the live session, bro. It's already time. Let the others join. If you have any doubt, if it is concerning the assignment given to you by your course coordinator, then I cannot solve that doubt. I can only give you some practice questions. You can solve those, okay? Okay. Is the screen visible? Gaurav? Is the screen visible, Gaurav? Please. Yeah, okay. I'll just start. I don't know whether I've attended the previous classes or not. Can you say something? Yes, okay. I don't know whether you have attended the previous class or not, but this is a live session. This is the fifth live session on Geotechnical Engineering 1. I'm going to give you some set of questions along with numericals, and after I dictate the questions, I'll give you some time, 10-15 minutes, to solve those answers. After that, I will discuss those answers one by one. Okay, so I'll start. This is the fifth live session on Geotechnical Engineering 1, and today's topic is soil water statics. Okay, so the first question is, coarse grained soils have relatively low hygroscopic moisture due to their. What is the reason for the low hygroscopic moisture of coarse grained soils? The options are greater angle of internal friction, limited specific surface, low cohesion, or none of these. No need to answer right now. You can just write down the question and the options. I'm going to just give you these questions right now. Just note it down along with the options. Okay. I'll give you time to solve these questions. I'll give you 10-15 minutes to solve these questions. After that, I will discuss every question along with the answers. Okay. Just write the questions and the options right now. Okay. So the question is, coarse grained soils have relatively low hygroscopic moisture due to their. The options are greater angle of internal friction, limited specific surface, low cohesion, or none of these. Okay. Next question. Almost reversible swelling and shrinkage on re-wetting and re-drying can be observed in soil having high content of. Hello, you joined late, Dr. Roy. Okay, it's still time. Just write down the first question. I'll just repeat the first question for the one who joined now. This is the fifth live session, and the first question is, coarse grained soils have relatively low hygroscopic moisture due to their. What is the reason behind the low hygroscopic moisture of coarse grained soil? The options are greater angle of internal friction, limited specific surface, low cohesion, or none of these. This is the first question, and the second question is, almost reversible swelling and shrinkage on re-wetting and re-drying can be observed in soil having high content of? The options are silica, illite, montmorillonite, or kaolinite. I'll repeat the question. Almost reversible swelling and shrinkage on rewetting and redrying can be observed in soil having high content of. The options are silica, illite, montmorillonite, or kaolinite. Next question. This property offers an explanation for the bulking of sand. This property offers an explanation for the bulking of sand. The options are slaking, high friction angle, activity, or apparent cohesion. I'll repeat the question. This property offers an explanation for the bulking of sand. What is the explanation for bulking of sand? Which of these phenomena can offer an explanation for the same? The options are slaking, high friction angle means angular mutual friction, activity, or apparent cohesion. Next question. The maximum capillary tension for a tube of 0.05 mm diameter for water at 4 degrees centigrade is. The maximum capillary tension for a tube of 0.05 mm diameter for water at 4 degrees centigrade is. The options are, I believe it will be in kilonewton per meter square. Okay, ignore the unit, I'll change the unit afterwards. The options are 6.05, 7.03, 6.62, or 7.05. The maximum capillary tension for a tube of 0.05 mm diameter for water at 4 degrees centigrade is, in Kn per meter cube, the options are 6.05, 7.03, 6.62, or 7.05. Okay. Next question. Next question is, the pressure transmitted from particles through their points of contact through soil mass is called. The pressure transmitted from particles through their points of contact through soil mass is called. The options are neutral pressure, total pressure, effective pressure, or saturated pressure. I repeat the question. The pressure transmitted from particles through their points of contact to soil mass is called. The options are neutral pressure, total pressure, effective pressure, or saturated pressure. Next question. Entry of air into the void spaces of clays during drying below shrinkage limit, followed by immersion in water, causes. The options are swelling, slaking, shrinking, expansion. Entry of air into the void spaces of clays during drying below shrinkage limit. When a sample of clay is dried, it is dried below shrinkage limit, then air it enters into the void spaces. Now afterwards, if it is followed by immersion in water, then what will happen? What is the phenomenon called? The options are swelling, slaking, shrinking, or expansion. Again, Gaurav Raj, you need to write the answer in the chat box. Just solve it. I'll give you time to solve all the answers. Okay. You need to write the answers in the chat box. You can just solve the questions right now. It's okay. Just solve these questions. I'll give you enough time to solve the answers after I dictate all the questions. Okay, so the question was entry of air into the void spaces of clays during drying below shrinkage limit, followed by immersion in water, causes. The options were swelling, slaking, shrinking, and expansion. Next question. When the water level in a lake or tank rises, the effective stresses in the soil below are. When the water level in a lake or tank rises, the effective stresses in the soil below are. The options are increased, decreased, depends on the particle size, or remains constant. Yes.
I have query about assignment 5.
Wait, Gaurav. Assignment 5, which question you have query? The question given to you by DN Singh sir, right?
Yes, yes.
Yes, but I am not allowed to solve your assignment questions. Okay. I am here to give you
Assi-
sufficient. I am here to give you practice questions so that you can solve the assignment questions on your own. Okay. This is just a discussion class.
assignment is completed.
Anything
Is com-
okay, no. See, anything concerning your assignment questions given to you by DN Singh sir. Okay. I am not supposed to discuss those questions. Okay. That is solely given to you by your course coordinator. Okay. Any other thing which you have in doubt, I can discuss that. But anything concerning the assignment questions given to you by your course coordinator, I am not allowed to discuss those. Okay, I'm sorry. You can have if you have any other doubt, you can ask here, or else you just write down all the questions. These are the practice questions.
dot
Hello.
dot
Gaurav, your voice is breaking. You can write in the chat box what is your doubt.
okay.
Your voice is breaking. You just mute yourself and write in the chat box. Okay, so the question was, the last question was, when the water level in a lake or tank rises, the effective stresses in the soil below are. The options were increased, decreased, depends on the particle size, or remains constant. My answer is right, but count as wrong. Okay, I cannot help that. I'm just here to guide you for your course through these live discussions. Okay, you can talk to the relevant NPTEL coordinator or your course coordinator if you think your answer is right or it was counted as wrong. But I am just assisting you for your course to gain insights into your course and solve questions in a better way. Okay, Gaurav, I'm sorry, but I cannot solve that. Okay, meanwhile, you can solve these questions. Okay, the answers I'll give you time to solve. Okay, effective stress in the soil below, it increase or decrease, remain constant. Okay, next question. The effect of capillary saturation will cause the effective stress to. The effect of capillary saturation will cause the effective stress to. The options are increase, decrease, can be both, or remain constant. Don't write the answer. If you're writing the answer, you're giving the solution to everyone. I'll give time to everyone to solve the questions. Just solve what you want. Okay, the effect of capillary saturation will cause the effective stress to. The options are increase, decrease, can be both, or remain constant. Alright, next question. Structural water can be removed by oven drying at 55 to 65 degrees centigrade. Structural water can be removed by oven drying at 55 to 65 degrees centigrade. Is this statement true or false? Structural water can be removed by oven drying at 55 to 65 degrees centigrade. True or false? Next question. In the capillary saturated zone, the pore pressure is. In the capillary saturated zone, the pore pressure is. The options are tensile, compressive, can be both, or zero. In the capillary saturated zone, the pore pressure is tensile or compressive, or can be both, or it is zero. Next question. Water table was found 1 meter below the ground surface. Above the water table, the soil was saturated with capillary water. If the saturated unit weight is 18 kilonewton per meter cube, the effective stress at the water table level in kilonewton per meter square, it will be in kilonewton per meter square is, the options are 8, 9, 18 or 0. Is this question clear? Is this question clear in everyone? Water table was found 1 meter below the ground surface. Above the water table, the soil was saturated with capillary water. If the saturated unit weight is 18 kilonewton per meter cube, the effective stress at the water table level in kilonewton per meter square is, one information is missing over here. You can assume the unit weight of water as 10. Okay, 10 kilonewton per meter cube. To find the effective stress at the water level in kN per meter square, the options are 8, 9, 18 and 0. Okay, next question. Hygroscopic moisture can change due to gravity or capillary action only. Hygroscopic moisture can change due to gravity or capillary action only. Is this statement true or false? Hygroscopic moisture can change due to gravity or capillary action only. True or false? Next question. Neutral pressure is always tensile, always compressive, compressive below water table and tensile above it, compressive above water table and tensile below it. Neutral pressure is always tensile or always compressive, compressive below water table and tensile above it, compressive above water table and tensile below it. Okay. Next question. The effective stress in kilonewton per meter square at a depth of 10 meter below the ground level when water table is 3 meter below the ground level. Saturated density is 20 kilonewton per meter cube and bulk density is 18 kilonewton per meter cube is. I repeat the question. The effective stress in kilonewton per meter square at a depth of 10 meter below the ground level when water table is 3 meter below the ground level, saturated density is 20 kilonewton per meter cube and bulk density is 18 kilonewton per meter cube is. The options are 154, 124, 194 or 144. Again, in this case, the weight of water is not given. You can assume it to be 10 kilonewton per meter cube and solve the question. I'll repeat the question. The effective stress in kilonewton per meter square at a depth of 10 meter below the ground level when water table is 3 meter below the ground level, saturated density is 20 kilonewton per meter cube and bulk density is 18 kilonewton per meter cube is. We have to find out the effective stress at 10 meter depth below the ground level. The options are 154, 124, 194 and 144 in kn per meter square. Okay. Next question. In the capillary fringe, the effective stress is less than the total stress, greater than the total stress, equal to the total stress, or can't be said. You have to tell me the relationship between effective stress and total stress. The capillary fringe means where the capillary action of water is taking place in that zone, the entire capillary fringe zone. The effective stress is whether less than total stress or greater than it or equal to it, or it can't be determined. Someone has joined right now. Please write in the current question. I'll give you time to solve the answers and you can revise. You can write down the answers when we start discussing. Okay. So the question was, in the capillary fringe, the effective stress is less than the total stress, greater than the total stress, equal to total stress, or it can't be said. Okay. Next question. Softening of soil due to melting of ice is commonly known as. Softening of soil due to melting of ice is commonly known as. The options are frost heave, bulking, slaking, or frost boil. I'll repeat the question. Softening of soil due to melting of ice is commonly known as frost heave, bulking, slaking, or frost boil. Next question. A river 5 meter deep consists of a sand bed with saturated unit weight of 20 kilonewton per meter cube, where gamma W is being given, the weight of water is being given as 9.81 kilonewton per meter cube. The effective vertical stress in kilonewton per meter square at 5 meter from the top of sand bed is. I'll repeat the question. A river 5 meter deep consists of a sand bed with a saturated unit weight of 20 kilonewton per meter cube, and gamma W is given over here 9.81 kilonewton per meter cube, so we need to assume it as 10. Again, those of you who are joining right now, please start from the current question. A river 5 meter deep consists of sand bed with saturated unit weight of 20 kilonewton per meter cube, gamma W as 9.81 kilonewton per meter cube. the effective vertical stress in kN per meter square at 5 meter from the top of sand bed is, the options are 41, 60, 50 or 51. Depth of river is being given, saturated humid weight has been given, gamma W is given to find out the effective stress at 5 meter below the top of sand bed. Someone's mic is on. Please unmute. Please mute yourself. Thanks. Okay. Next question is, the depth of water in a swimming pool is 6 meters. The total and effective stresses in kilonewton per meter square at a depth of 3 meters from the top surface of water is 10, 30. That is the total and the effective stress. Both the values are given 10, 30, 20, 20, 0, 30 or 30, 0. The depth of water in a swimming pool is 6 meters. The total and effective stresses in kilonewton per meter square at a depth of 3 meters below the top surface of water is 10, 30, 20 and 20, 0 and 30 or 30 and 0. Next question. A 2-meter thick sand layer of density 1.7 ton per meter cube overlies a 4-meter thick saturated clay of density 2 ton per meter cube. If the water table is at the interface, the effective pressure in ton per meter square at the center of the clay layer is, in this question, you don't have the unit weight of water. Assume the standard unit weight of water in kg per meter cube and convert it into ton per meter cube. Okay. So the question is, a 2-meter thick sand layer of density 1.7 ton per meter cube overlies a 4-meter thick saturated clay of density 2 ton per meter cube. If the water table is at the interface, the effective pressure in ton per meter square at the center of the clay layer is, the options are 7.4, 5.4, 2.0 or 3.4. I'll repeat the question for
Sir,
yes, who is it? Abdul. Your mic
Yes,
is
sir.
on. Your mic is on, I think. You want to say something?
means of interface.
Water is at free surface. Water is at the interface means at the junction of the two layer. There is, see, look at this question. There is a sand layer, after which there is a clay layer. The interface means the junction of two layer. Okay. Water table is at the junction of two layer. 2-meter thick layer of sand and then 4-meter thick layer of clay, saturated clay. At the junction of two layers, the water table is present. Then you have to find the effective pressure at the center of clay layer, center line of clay layer, to find the effective pressure. Clear? Option B. You need to tell me the option right now. I'll give you time to solve these questions. Okay. Is this question clear? Where is the water table located? Yes, one of between the two. Yeah, that is what interface means. Meter thick sand layer of density 1.7 ton per meter cube overlies a 4 meter thick saturated clay of density 2 ton per meter cube. If the water table is at the interface, the
B
effective
option.
pressure in ton per meter square at the center of the clay layer is 7.44, 5.4, 2.2, 3.4. Okay. Next question. Please draw this diagram. This is, I think, from some previous year's question. Given this question, previous year's question, I think. Please draw this diagram. Can everyone see the diagram in the PPT? It is visible, right? The diagram. Okay, if it is not visible, I'll tell you. This is a sand layer, 5 meter thick.
PPT.
Yeah. At point P, you have to find out the effective stress, total stress, and pore pressure at point P, where the water table is at the ground level. Water content is 20%. Specific gravity of soil solids is 2.7. Water unit weight is 10 kilonewton per meter cube. And the first part of the question is you have to find the saturated unit weight of sand. You have to first find out the saturated unit weight of sand, after which you have to calculate the total stress, the pore pressure, and the effective stress at the point P, that is below 5 meter below the ground level. Okay. Is it clear, everyone? The question? If you have finished writing, you can tell me. I'll give you some time to solve the questions. Has everyone finished writing on the questions? Okay. I believe everyone has written the questions. I'll give you some time, 10 minutes to solve. I'll start at 5:55. Okay. You solve these questions. Saturated unit weight. No need to tell the answers right now. You can solve it on your own. I'll give you time. I'll discuss all the answers along with the procedures. Okay. So if you have done the questions, let the others solve by themselves. I'm giving you 10 minutes time. Everyone solve all the questions. Once you solve, you can raise your hand. I'll start at 5:55. I'll start discussing all the answers. Okay. And if you have any doubt, if you have any answers whatsoever, you can tell at that time. Okay. So do it. Have you completed the answers? Can we start discussing the answers now, everyone?
Yes, sir.
Okay, I believe everyone has completed the answers. Okay, so the first question was, coarse grained soils have relatively low hygroscopic moisture due to their which property? What is the answer?
Angle of internal
Angle of internal friction. B. Specific surface. B. Abdul Rafi. The answer is, coarse grained soil have low hygroscopic moisture due to their limited specific surface. Because hygroscopic moisture is the adsorbed moisture due to adhesion on the surface. So coarse grained soil have less specific surface than fine grained soil. Specific surface means surface area per unit mass. When surface area is divided by mass, we get specific surface or specific surface area. Specific surface area for coarse grained soils, it is less than the fine grained soils. Obviously, because they have larger grain size. And because of this property, fine grained soil have high hygroscopic moisture content, but coarse grained soil, they have low hygroscopic moisture content. So this low moisture content in the form of hygroscopic moisture is due to their limited specific surface. Okay, clear? Okay, next question. Go to the next question. If you have any doubt, you can just stop me and ask. Almost reversible swelling and shrinkage on re-wetting and re-drying can be observed in soil having high content of. What is the answer?
Morris.
C. Montmorillonite. Yes. The mineral montmorillonite is responsible for swelling in many kinds of soil, especially in black cotton soil. This mineral have high interlayer swelling. Okay, so the one which has high interlayer swelling is also the one which has shrinkage on reduction in moisture content. Hence, when we pass a soil into re-wetting and re-drying cycles, then we can observe swelling and shrinkage at a high amount, and that reactions will be almost irreversible, almost reversible, because the one which will swell, it is the one which will shrink. That will happen in the presence of this particular mineral, montmorillonite. Okay, illite and kaolinite, they are stable minerals. Yes, Abdul, you have a doubt?
Sir,
Hello. Yeah. Your voice is not audible. Please, you write in the chat box first. Units of specific surface area. What is the definition of specific surface? I told you. Surface area per unit mass. So you have surface area, you have mass. Divide that, you get the unit. Specific surface area and specific surface are the same thing. It is surface area per unit mass. So when you divide the unit of surface area per unit mass, okay, per unit mass, not volume. Surface area per unit mass, okay. So area is meter square, mass is kg. So meter square per kg, centimeter square per gram, like this, okay. Clear, Abdul? If your doubt is clear, but in books both are given, sir. Okay, might be both are given, but generally, see, there is a general definition, and in some places there might be something specific which is applicable to some particular, some special cases. Generally, we consider this area by mass as a general thing. Okay, so specific surface area per unit mass, surface area per unit volume. I haven't seen it. If you have seen it in any book, it will not be wrong, but that will be applicable to some special cases. In general terms, specific surface or specific surface area is surface area per unit mass. Okay. There might be many problems, many geotechnical problems where it will be required to calculate the surface area per unit volume also. Okay, but generally surface area per unit volume, it will not be so much relevant, because you're finding out area in meter square and then you're dividing it by volume, that's meter cube. You'll get something in per meter, isn't it? So I don't think that will be much relevant, but again, there can be many kind of geotechnical problems where we might need to calculate the surface area per unit volume. So, but in general cases, it is area by mass. Okay. Okay. Next question. This property offers an explanation for the bulking of sand. What is the answer? Apparent cohesion, is it, Abdul? Who answered? Ashok. Anyone else? What is the answer? I cannot see the PPT properly. Can you see it now? I'm just toggling between the PPT and the Google Meet, because if you ping me the answer, I will be able to see, right? So can you see the PPT now? This property offers the explanation for the bulking of sand. Slaking, high friction angle, activity, or apparent cohesion. The answer is apparent cohesion. Whoever said the answer, you are right. Apparent cohesion is the answer. The reason is the interparticle attractive forces, they form a honeycomb like structure, okay, in the capillary fringe when water is being added up to a certain level of moisture content, and that causes the increase in the volume, or in other words, the bulking of sand. So the interparticle addition happens when we add moisture in the beginning due to capillary action of water, okay, and that is more prominent in the fine grained sands. If here we put moisture content in percentage and here we put bulking, that is volume increase, in percentage, we'll see that the graph will be like this, and it will be like this for this is for coarse grained soil, and this is for fine grained soil. Okay, so the fine grained soil, due to their more specific surface, they will be able to give more adhesive forces, forming a better honeycomb structure in the capillary action of water, and hence they will show more bulking than the coarse grained soil. And this percentage of water at which it happens, it is generally 5 to 6%. Okay, so this phenomenon can be explained by apparent cohesion, because sand particles, they do not have cohesion, right? They are actually cohesionless soil, but these interparticle adhesive forces make it seem that they are having cohesion. Okay, so apparent cohesion gives an explanation for the bulking of sand. I hope it's clear. Any doubt? Okay, next question.
Sir.
Okay. The maximum capillary tension for a tube of 0.05 mm diameter for water at 4 degrees centigrade. What is the answer? Anyone have solved this question? What is the answer? Anyone have solved this question? If you haven't solved, if you can't solve, you can tell me. Okay, let's paint. D. No. Okay, so you don't know the formula, I guess. At 4 degrees centigrade, the maximum height of capillary action you need to first calculate. Okay, AC max. A. Yes, A is the answer. I'll show you how. Okay, who told A? Ashok, right? Gaurav. What is the formula, Gaurav? For AC max at 4 degrees centigrade for water? The formula is 0.3084, right? 0.3084 divided by, it is the diameter in centimeter, and by that you can find out the HC max in centimeter. The value I think is around 0.617. Yes, 0.617. I believe that is in meter. 0.617 meter. And now the tension, capillary tension, if you want to find out max for HC max, will be this HC max into gamma W. Gamma W is, take it as 9.81. You can get the answer as 6.05. Okay, if you take it as 10, then you will get 6.17, but I haven't given that because for this kind of question to find out the capillary tension, the water temperature and the exact gamma W is very important. Hence, 9.81 should be taken, and if you multiply that, you will get 6.05 as the answer. 6.05 kilonewton per meter cube. Okay, clear all of you? Any doubt? Anyone? 0.6.2, 9.81. Yeah, 0.6.2 or 6.7, something like that. Yes, someone has some doubt? Why units are given in kilonewton per meter cube? Which unit? Capillary tension. Yeah, I have said in the beginning the units are wrong over here. Please correct it yourself. I haven't corrected it yet. Okay, let me. The units will be in kilonewton per meter square. Okay, I'll just correct it now. Just give me some time, because this gamma W is kn per meter cube. It will be kn per meter square. I have told in the beginning this is incorrect, but I haven't corrected it. Thanks for reminding, Ashok. Capillary tension, I'll write it here in kilonewton per meter square. Okay. Tension and pressure and stress always in kilonewton per meter square. Yeah. Okay. So the next question. The pressure transmitted from particles through their points of contact through soil mass is called. What is the answer? I think your mic is having some problem. Whoever had unmuted. C. Yes, it's called effective pressure. The pressure given by the soil particles, the grain to grain transfer of the load throughout the soil mass. That pressure is called the effective pressure. Here we do not consider the effect of water, or we do not consider the pore pressure coming into action. Okay, we consider the grain to grain transfer of the load from one soil particle to the other. Yes, you are right, effective pressure. Next question. Yes, effective pressure. You are right. Entry of air into the void spaces of clays during drying below the shrinkage limit, followed by immersion in water, causes. What is the answer? Any answer for this? B. What is B? Slaking. Swelling. No. The one who told slaking, Abdul Rafi. Yeah, slaking. Can you explain what is slaking? I have just given a general description of slaking over here, but the mechanism is when clay is being dried. Okay, we dry the sample of clay below the shrinkage limit. Then what happens? Below shrinkage limit, if water content is reduced, the volume is not reduced, right? Below shrinkage limit, because what is the graph? The graph of moisture content with volume is like this, right? This is the shrinkage limit, this is the plastic limit, and this is the liquid limit. So when we reduce the moisture content below the shrinkage limit, the volume remains constant, right? If the volume is constant, then the water from the pore is being drained out. Then what will occupy the void? Air. Okay, So drying below shrinkage limit, air enters into the void spaces. Now after drying, suppose up to this level we dry it, and immediately after that we immerse the, yes, breaking down that the mechanism I'm trying to explain. We immerse the sample into water. What will happen? The pores which were dry, which had air, okay, their high pressure will be generated because of the inflow of water. And due to this high pressure formed because of the meniscus formed due to the presence of water over there, that high pressure will cause the disintegration of the soil particles, of the clay particles. And that disintegration of the clay particles due to this high pressure, due to immersion in water, which was previously preceded by drying below shrinkage limit, forms slaking. Okay, so there are some steps. First of all, you need to dry the sample below shrinkage limit and then immerse it in water, and then water enters into the voids where air was present previously, and then because of the high pressure of the water in the meniscus, the soil particles, they start disintegrating, and this process is called slaking. So is the mechanism clear of slaking? The actual thing is, yes, breakdown of large particles, not large particles, the disintegration of the entire soil particles. Because clay particles, we know the particle size of clay is small. Okay, yes, Abdul Rafi.
Sir,
Yes. Abdul, your mic is not working, I think. Please write in the chat box. Yeah, thank you, Revati. In video. What in video? What do you want to see in video? Video of NPTEL lecture. Okay. Sir used. Write it at once. No? Why are you causing suspense? Sir used dry state. That is the thing, no? Dry state, not dry state. See, it can be dry state, no? If in the first step, what am I doing? I am drying below shrinkage limit. So I can dry it till here also, right? Zero moisture content. That can be also dry state. What? Can you explain what are you trying to say? Here it is partially saturated. See, I'm talking about drying below shrinkage limit. That can be any value. If shrinkage limit is something, let's say shrinkage limit is 10. Okay, this is 10. So drying below shrinkage limit is any value from 0 to 9, I can say. So if I take 0, sample is dry, and if that sample I immediately immerse in water, that will cause slaking, right? SL means saturated soil.
can you hear me, sir?
Yes, I can hear you.
Yeah. Hello.
From 0 to shrinkage limit, soil should be what? PS, partially saturated. Yes, soil is partially saturated, yeah, because water is still present in the soil.
Limit.
Hello?
But in the NPTEL,
In the NPTEL video, sir has told that the soil should be dry for slaking to occur. Is it? Have I understood it right that in the NPTEL video you have learned that the soil should be absolutely dry for slaking to occur? Please mention it fast. We have more questions to cover. just clear your confusion once. Slaking of soil, because I have made these questions using a standard textbook, slaking of clay. Yes, the book I am concerning for making these questions, standard textbook soil mechanics, BC Punmia, soil mechanics and foundations. From there, I have mentioned in this question, drying well below shrinkage limit, attainment of minimum volume. So this question is correct. Drying below shrinkage limit, attainment of minimum volume. Okay. So when the soil is dried below shrinkage, as per the book, as per the BC Punmia book, if you dry it below shrinkage limit, then immerse it in water, it might cause slaking due to the inflow of water and increment of water pressure. Okay, you might get your doubts cleared from some other, if you refer to some other books, but the book which I have consulted, even this and another book called Gopal Ranjan Rao, there I think I have seen in both the books that drying below shrinkage limit is the first step for slaking in clay. Okay, but please get your doubts cleared. Okay, if you can like consult any other book.
Can you hear me, sir?
Yes, Abdul, I can hear you.
Sir, in the NPTEL video,
Yes, NPTEL video. Yes,
we have a
Abdul, your voice is not clear. Please write down please write your doubt in the chat box fast and write in a single sentence. Okay, Abdul, you write your query. I'll just move on to the next question. Okay, we'll come back to this later. But this is the actual mechanism of slaking which I've mentioned, as mentioned in the standard textbook. The next question is, when the water level in a lake or tank rises, the effective stresses in the soil below are. What happens? What is the answer? No change. Yes. When the water level rises, the sigma dash, that is the effective stress, it remains constant, because effective stress means the stress given by the soil particles, grain to grain transfer of soil particles pressure. So it has nothing to do with the change in the water level. So it remains constant. Effective stress remains constant. Okay. Yeah, Abdul, have you written down it out? Okay, no change. Just a moment. Question needs slight change. Which question? Which question needs slight change? Abdul, the present one. What is the change you need? This one. Water level in the lake or tank rises. What is the change you need? You write the entire thing in a single line. Don't write one by one. Water level above ground level, it should be. Water level above ground level. When the water level above the ground level, if it is a tank and there is soil in the tank, can the soil be called as the ground level? If it is a tank located in the on the roof of your building and it has soil below in the tank, can the soil be called as a ground level? If it is a lake and the lake has some soil deposit below, can the soil be called as a ground level?
No, sir.
So water level in a lake or tank, it rises. The effective stress in the soil below. I have mentioned the soil below. That is the soil below the soil below the water level in the lake or tank. Whatever the soil is, wherever the soil is, how will the effective stress change? It will not change. It will be constant. Okay. Next question. I have mentioned lake, but if the soil is below the lake, can the soil be called as a ground level? The effect of capillary, when the water level above the bed rises, then only no change occurs. You are talking about ground level only. You have solved questions on ground level or something like that. You are talking about ground level only. I am talking about general water, then soil. This soil can be ground level. This soil can be below the lake. This soil can be the soil below a water tank. Okay, that is not the ground level which we say in general sense. Ground level is the mean sea level, we call it. Okay. The effect of capillary saturation will cause the effective stress to, what is the answer? Anyone? What is the answer? Increase. Yes. Because capillary suction is equal to negative pore pressure. And negative pore pressure means it will add to the effective stress. Hence, effective stress will increase due to capillary suction. Good. Structural water can be removed by oven drying at 55-65 degrees centigrade. True or false? Structural water can be removed by oven drying at 55 to 65 degrees centigrade. True or false? False. Yeah. It cannot be removed even at 105 or 110 degrees centigrade because it is structural water. It is chemically bound. Next question. In the capillary saturated zone, the pore pressure is, what is the answer? Tensile or compressive? Or both or zero?
Both.
Both. No, Gaurav, even in 105 to 110, structural water can't be removed. Yeah, the present question. Tensile or compressive or both? Tensile. Gaurav. Yes, in the capillary zone, the pore pressure is tensile. This is the tensile zone, tensile force. This is the compressive force, and this is the capillary zone. Capillary zone. So this pressure is tensile pressure. Okay. Next. This question, water table was found at 1 meter below the ground surface. Above the water table, the soil was saturated with capillary water. The saturated unit weight is 18. Effective stress in kN per meter square is. What is the answer? What is the answer? This is capillary action, right? C. C is the answer. Yes, C is the answer. Why? Because when capillary action is present, okay, then the value of effective pressure is gamma sat into Z, that is 18 into 1, that is 18. 18 kN per meter square. Total stress is equal to effective stress. Yes. Good. Okay. So this question is done. Next question. Hygroscopic moisture can change due to gravity or capillary action only. True or false? Anyone? Hygroscopic moisture? What is hygroscopic moisture? Yes, Ashok. What is hygroscopic moisture? Absorbed or adsorbed? You have written absorbed. Is the word absorbed or adsorbed? Absorbed. What is the difference between absorption and adsorption? I'm writing in the chat box. What is the difference between adsorbed and absorbed? Adsorption due to charges. Yes, adsorption due to charges. I think you have made spelling mistake previously. Adsorption due to charges. So it is film, like a film, it is formed on the surface. Okay, due to adhesion properties. So that property, can it change due to gravity or capillary action? No, because it is an inherent property. It is dependent upon the soil structure of the soil particles, and obviously it is dependent on the specific surface of the soil. Okay, high for fine grained soil and low for coarse grained soil. Yes. So how it can be true? I'm telling you the reason. How can it be true? If this moisture is dependent on the soil properties itself, how will gravity or capillary action have an effect on this property? Tell me. I'm considering a soil grain. I'm considering the effect, the adhesion property on this particular grain. Does gravity or capillary action have any effect on the adhesion property of this grain? Yes, temperature, pressure are some property which may have effect on the fluid which is getting absorbed, on the water getting absorbed. So we are only concerned about the soil particle and the moisture on the surface of it. So those factors which can affect either the moisture, water, or the soil particle, those will have influence on this kind of moisture. Okay. So here in this case, since gravity or capillary action, none can have any effect on this property. This is false. It cannot change. It will not change because of any change in gravity or capillary action. Okay. Okay. Next question. Neutral pressure is. I have solved one thing before. It is the same thing afterwards. What is the answer? Neutral pressure is D. Compressive above. Someone said C, someone said D. Abdul Rafi. Compressive above the water table and tensile below it. And Gaurav said D. Gaurav, you're not right. I think Abdul is right, because I have just now said the diagram I have drawn. If something is above the water table, That means it is saturated by capillary action. Then in that capillary fringe, the pressure is tensile. This is the water table. Then above it, there is pore pressure acting above the water table. Then that is capillary action, and the pressure is tensile. However, in the water table, below the water table, the soil is saturated, and hence the pressure is compressive. So compressive below water table and tensile above it. This is the correct answer. Clear? Gaurav? Is it clear? Because above the water table, when we are talking about pore pressure or neutral pressure, it can only be due to capillary action, which is tensile in nature, because it adds to the effective pressure. Yes, okay. Next question. Okay, before going to the next question, because next I think few questions. Okay, I can wait for one more question. I'll just ask who was that who told about the ground level. The ground level doubt is solved, right? You don't have any query regarding the ground level. I think it was Abdul, right? Who was asking me questions about the ground level, whether it should be ground level. Yes, Abdul. Is it clear why the question was not mentioning ground level? It was mentioning only soil? Yes. If you have any doubt remaining, please stop me and ask me, okay? Yes. The next question. Effective stress in kilometer per meter square at depth 10 meter below the ground level when water, I have mentioned ground level now. When water table is 3 meter below the ground level and saturated density is 20 kN per meter cube and bulk density is 18 kN per meter cube. Okay. So how will you draw this? What is the answer first of all? Anyone who solved? What is the answer? Have you solved anyone? Okay. So effective stress at depth of 10 meter. This is the ground level. Water table is 3 meter below the ground level. A depth of 10 meter. Further to 7. So this is 3. This is 7 meter. Saturated density, this is the water table. So saturated density gamma sat over here is 20 and bulk density gamma T here is 18. B 124. Okay, let's see. So what will be the effective stress at this position? This is suppose x dash. So sigma dash equal to, it will be first of all the first layer 18 into 3, right? Effective pressure equal to total pressure because there is no water, and we are adding here. Nothing is mentioned about the gamma W, so you can take 10. I have told you in the beginning, nothing is mentioned in this kind of question. You can take 10. 20 minus 10 effective pressure gamma sat minus gamma W gives us gamma submerged into 7. So here we get 54 we get over here and 70 we get over here. It is I think 124, isn't it? 124 kN per meter square. Is it clear everyone? Yes, someone was saying, sorry. 18 into 3 plus 10 into 7. Yeah. Good. Same thing. Is it clear for everyone? Since I am mentioning over here effective stress, hence for this thing, for the second layer below the groundwater level, I have to take gamma submerged. This is gamma submerged. Okay. This value 20 minus 10 is gamma submerged. Okay, into H, and over it gamma T into H. Okay. So it is 124 kilonewton per meter square. Okay, next question. In the capillary fringe, the effective stress is, what is the answer? This is easy question. What is the answer, Abdul? If in the capillary fringe, I'm talking about this kind of pressure diagram, right? They have mentioned in the previous two questions. A, less. Effective stress is generally less than total stress. But if I'm talking about the capillary fringe, okay, in this capillary fringe, the pore pressure is negative, right? This is the pore pressure diagram. It is negative and this is positive. So if the pore pressure is negative and this is the water table, in general cases, what we see that total pressure equal to effective pressure plus U, right? Isn't it? Because total pressure is the grain to grain transfer of the soil load, added on to it is the pore pressure. But in this case, the pressure is negative. The pressure is negative, right? So in this region, what will be the value? Total pressure equals to the soil pressure, that is the effective pressure, minus U, isn't it? And for this region, it will be this thing, effective pressure plus U. Is it clear, everyone? Sorry, sir, answer is B, I think. Greater than the total stress. Yes. Yes, answer is B, greater. Okay. So here the effective stress is total stress plus U. So effective stress is more than the total stress. Okay. And one interesting thing is at this level, at this junction, okay, what is the value? Effective stress equals to total stress. Both are equal. Very good. Both are equal. So in this capillary fringe, that means specifically in this zone, the effective stress will be greater than the total stress. Okay. I believe it is clear to all of you. Any doubt? Anyone? Any doubt? Anyone regarding this particular question? Because this is a conceptual question. You have to get your concepts clear. Okay, I'll move on to the next question. I think I have three questions left. Yeah. So this is option B. This is the answer. Effective stress is more. Next question. Yes, softening of soil. Softening of soil due to melting of ice is commonly known as. What is the answer? This melting of ice, it happens in the capillary fringe generally. Okay. D, frost boil. Yes, D is the correct answer. Before frost boil, frost heave occurs due to freezing and increase in the volume, freezing of the water in the pores. Now when the water which are frozen, that is the ice in the pores, they start melting. Okay, they form a capillary fringe, and because of this melting, there is increment in pressure again over here, and because of this melting, the soil it softens. Okay, the soil which softens on melting, increment in water content because of the melt is the first and foremost important parameter, because of which the soil is softening in the capillary fringe. So that leads to the phenomenon called frost boil. Yes, who gave the answer? God of, yes, soil consistency. Consistency increases. Abdul, do you think consistency increases if the soil is softening? In the first class, not in, I think you are not there. Consistency and liquidity, these are both two different concepts. So consistency, generally we define consistency as the ease with which the soil can be deformed, and consistency index. Yes, if you say consistency in the general term, the ease with which the soil can be deformed, okay, then the soil can now be deformed with at a lesser ease or a greater ease because it has softened. But in terms of consistency and liquidity, water content and increases, I know. In terms of consistency and liquidity, if you say the toughness which increases due to increase in the consistency index, then I will say that, that the consistency has reduced and liquidity has increased. Okay, so consistency has two forms. One is a general form where we mean consistency that it is the ease with which soil can be deformed, and specifically consistency index. There is a term called consistency index. The higher the value of consistency index, the tougher the soil is and the better the soil is. Okay, so in terms of consistency index, this soil has degraded. In terms of consistency, the soil can now be deformed with a greater ease. Is it clear, all of you? Yes, water content increases, soil consistency increases because now the soil can be deformed. Yes. So when you say consistency, keep in mind that consistency can mean two different things. If you use the word consistency in a general term, or you use the word consistency specifically to signify consistency index. Okay. Please read about this consistency and liquidity index from any textbook or whatever source you can find. Okay. So here the phenomenon is called frost boil due to softening of soil, addition of moisture due to melting of ice. Right. Okay. A river 5 meter deep consists of a sand bed with saturated unit weight of 20 kN per meter cube. Gamma W is given 9.81. Effective vertical stress at 5 meter from the top of the sand bed. Yeah. Answer is D. Just check. This is 5 meter, and we are told to find vertical stress 5 meters from top of the sand bed. River. This is the river, so this is the water table. Yeah, this is the river. So this is 5 meter. Saturated unit weight of 20. This is gamma sat. This is 20 kN per meter cube. Gamma W is given 9.81. The effective vertical stress at 5 meter from the top. Effective vertical stress at 5 meter from the top. So that will be sigma dash, that will be equal to gamma sat minus gamma W, isn't it? So 20 minus, it will be 9.81 into effective stress. We are not going to consider this height, only this will be considered, into 5. What is the answer? Yes, I believe 20 minus 10, 5 into 50, it will be 51, right? 51 point something you're getting. Or 50.95 you're getting, right? 50.9 something. What is the answer? 50.9 something, right? Yeah, 50.95, right? So you can just round it off and say is 51. Five gamma W plus 5 gamma stat. Yeah, final stress you can easily find out using gamma sat only. Okay. But I'm talking about the effective stress over here. Yeah, very good. Final stress will be how much you have mentioned? Gaurav. 5 gamma W plus 5 gamma sat, or gamma W plus gamma sat plus 5, 149.05. Very good. Yes. So this question is clear. This solution is clear. Okay, we have many more questions. Depth of water at swimming pool is 6 meter. Total and effective stress and depth of 3 meter below the top surface is. What is the answer? D. Yes. Total stress is 30 because only water is present. Nothing is given. So consider 10 as gamma W. 10 into 3, 30. Effective stress, there is no soil present. So it will be 0. So 30 and 0 is the answer. 30 is gamma W into 3. Okay. Alright. Next question. A 2 meter thick sand layer of density 1.7 ton per meter cube overlays a 4 meter. Yes, you can write in the chat box. I believe none of your mic is working. 4 meter. Sand of density 1.7. So density is mentioned. I'll use rho 1.7. Okay. Water table at the interface. Here is the water table. Okay. So this will be saturated clay of density. This will be rho sat 2. Effective pressure at the center of the clay layer. Here. This is also 2 meter. This is x. This is also x dash. Okay. So gamma W is how much? It is 1 ton per meter cube, right? Effective stress in water is 0. Which question you are answering, Abdul? This one. The answer is B. Yeah, answer we'll see. Okay, first let me solve it. Just check it. Gamma W is 1 ton per meter cube because 1000 kg per meter cube. So, yes, 1. Yes, Abdul, you are right. So, effective stress will be, this is devoid of water. So, effective stress at x dash, effective stress will be equal to 1.7 into 2 plus gamma sat minus gamma W. 2 minus 1 into, this is height is 2 meter. So here it is 3.4 plus 2, 5.4. 5.4 ton per meter square. This is the answer. Clear? Yes, weight of water is 1 ton per meter cube. The answer is 5.4 ton per meter square. Okay. Yes, 5.4. Okay. Next question. This is the last question. Have you solved this? What is the saturated unit weight of sand?
21.
21. Let me check. Gamma sat equals to G plus E gamma W by 1 plus E, isn't it? What is E for saturated soil? E equals to actually WG by S. S is equal to 1, so it will be WG. So I think E you are getting something around 0.5, right? 0.54, right? 0.54. Here you have got G. You have got everything mentioned over here. G is 2.7. Gamma W, you have to take 10. 1 plus E, 0.54. I think something around 21.03 or 04. Isn't it? 21.04 I have got in Kn per meter cube. Anyone else have got any other answer? 21.03, 21.04. Yeah, that is the answer you will get for saturated unit of sand. Now the total pressure. How much? (105.19). Yes, and write 105.2. How you are getting? It is gamma sat sigma equals to gamma sat into 5. Okay, it is 105.2. What is the pore pressure? Yes, 105.2. What is the pore pressure? It's very easy. Gamma W into 5. 50. Because gamma W 10 is given over here. And what is the effective pressure? This minus this, so I think it's 55.2. Yes, 55.2. Someone has written down some answer. Pore pressure is 50. Yes. So this is, I'll write the formula sigma minus U equals to 55.2. Okay. Yes, 55.19. So I guess it is clear to all of you.
Yes, sir.
Yeah. Any doubt regarding any question or regarding anything else? I guess time is up. Just a minute. Yes. Thank you, Revati. How can I concern? How can you contact with DN Singh, sir? I don't know. You talk to your NPTEL coordinators. You talk to your NPTEL coordinator. I think they will guide you. Okay. Okay. So if there are no more issues, no more doubts, I think I can dissolve this session. Thank you everyone for attending the session. How can I talk to coordinator? You please check the NPTEL website and you can find out any email ID or something like that where you get the mail for the classes and everything. Go to, okay. You please please check that, and then you can talk, because anything concerning your weekly assignments given to you by DN Singh sir, I am not supposed to like talk about those things. Okay, so you find your way out, okay, and talk to sir. Okay, thank you so much. Bye bye. Sir, try to keep PPT constantly. Means, what is constantly, Abdul? Yeah, my method of live discussion is via PPT only, and every day I discuss via PPT, not able to see continuously. See, I have to see your answers. Today your mic was not working, so I have to see what you are giving the chat. I have to toggle between the Google Meet link and the PPT. So I guess today was a bit difficult for you because none of your mic was working properly. I had to see the chat box, I had to come back to the PPT and then tell you the answers on the question. Okay, so in the next class, try to work upon. Yeah, the mic was a problem. Okay, so if your mic is constantly working, I can hear what you are saying. I don't have to like toggle back to the Gmeet screen, right? I have to see the chat, what you are answering, and then solve your doubts. Okay, so next day it might not be a problem. Okay, thank you for attending the class. Bye bye. I'm leaving the meeting now. Yeah, bye. Good night.